What are the best 3D print settings for robotics parts? Imagine building a robot that can perform tasks with precision and strength. The secret lies in how you set up your 3D printer for those parts. When printing robotics components, you want them to be tough, accurate, and long-lasting. So, what settings help you get there? Let's break it down. First, choosing the right filament is key. For most robotic parts that need to handle stress, materials like polylactic acid pro, acrylonitrile butadiene styrene, polyethylene terephthalate glycol, or flexible thermoplastic polyurethane work well. Set the extruder temperature based on the filament. For polylactic acid pro, around 200 degrees Celsius is good, and for acrylonitrile butadiene styrene, about 240 degrees Celsius. The heated bed should be set to 55 degrees Celsius for polylactic acid pro and around 100 degrees Celsius for acrylonitrile butadiene styrene. Proper temperature settings help the layers stick together and reduce warping. Next, consider layer height. A layer height of 0.2 millimeters offers a good balance between detail and speed. If you need finer details, go lower, but expect longer print times. For faster prints where detail isn't as critical, higher layers work but might make the surface rougher. The number of perimeters, or walls, impacts strength. For robotic parts that need to withstand mechanical forces, 3 or more walls are best. This makes the outer shell more durable without adding too much time or material. Also, infill plays a big role. For parts that will face stress, an infill of 20 to 30% with honeycomb or triangular patterns provides solid internal support. These patterns distribute forces better than simple rectangular ones. Adding extra top and bottom layers, around 3 to 5, helps improve surface smoothness and strength, especially for load-bearing surfaces. Keep your print speed moderate, around 50 to 60 millimeters per second. This ensures good layer adhesion and accuracy. Cooling fans should be used especially when printing small features or overhangs, but for acrylonitrile butadiene styrene, cooling should be limited to prevent warping. Getting the first layer to stick well is vital. Use a heated bed, glue stick, or painter's tape to prevent warping and ensure the part's dimensions stay accurate. For parts that need tight tolerances, double-check your Z-axis calibration and make sure your dimensions are precise. If you plan to attach screws or bolts, increase shell thickness or infill near those areas for better anchoring. For flexible or impact-resistant parts, consider using thermoplastic polyurethane with the right temperature and print speed. Always test print-critical parts to verify strength and fit before making the final version. Adjusting these settings carefully helps produce robotic parts that are strong, precise, and ready for real-world use.